Okay. Good morning, students. And this is Shivash Patel, and welcome to MathSep YouTube channel. Okay. So yesterday we have discussed about the theory part of the binary operation, right? What is binary operation? That is the composition from A cross A to unique element, right? Ordered pair. So today, on based on these equations, we today this concept we solve this some examples. Okay. Okay, so this is the last class for this chapter. Last class for this chapter, I think so. So next we will start the, it depends on the time. Okay. First question is, okay. So I'm telling this is the source material ML Agarwal A-double-G-R-A, right? Agarwal book. The question is, let Z be the set of all integers and star be the operation on Z defined by. Okay, let question number 1 is Z. Okay, you know Z or Z is the set of all integers. Set of all integers, right? And operation, okay, sir, on Z integers and star be an operation on Z. Okay, sir, star be a operation on Z such that defined by A star B is equal to A plus B. For all AB belongs to Z. For all AB belongs to Z or Z. Okay, sir. Then you have to show commutative, associative, and AND element and inverse element. Right? You have to show commutative element. Commutative theorem, abelian group or commutative abelian. First one, okay, given. So let A B belongs to Z, right? And operation is and A star B is equal to A plus B. Okay, first one. Okay, let A star B is equal to A plus B. Okay, this is one. Again we can tell B star A is equal to B plus A is equal to A plus B. Can I write this one? B plus A. Right? A star B is equal to B star A. Are you getting or not? Same thing, same elements. Okay. B plus A is okay, sir. This implies that, okay. So A star B, okay, sir. A star B is equal to B star A. Okay. Before going this one, this is commutative. Therefore, Z is commutative or abelian. Before going to this one, you have to show, okay, sir, A plus B belongs to Z. Should one right? Because that is the Z integer numbers. Okay, A star B, which is belongs to Z, belongs to, because for all A B belongs to Z. Here you will get some confusion. Writing the board exam, you will get confusion. But whatever you write should be in order. But if it is okay, order means okay, that shall be order, shall be in order. But okay, if you are getting confusion, this it okay. It let us to know. Okay, let us consider some. You have made some rearrangements. Right? That's okay. Minor error, minor correction you can do. But when you are okay, so average students for excellent student, okay, they are toppers or and then out of our students, the extra category, this should be in order. Okay, you should be more, if you want to get more marks, out of what marks, the lines and the orders should be in order. Okay, order should be clear. Order should be in clear and manner. Okay, second one is, okay, Second one is associative. Okay, let's see A star. Okay, before that one, A, B and C belongs to Z, right? And A star B star C is equal to what? A plus B star C. This is equal to A plus B plus C, right? So this becomes A plus B plus C. Similarly, here A star bracket of B star C, bracket of B star C. This is equal to A star B plus C. This is equal to A B plus C. Therefore, so see here you can write A star plus B star is equal to G equal to also you can show, or therefore you can write also. Therefore Z is okay. Therefore Z is associative. See, I have not taken examples for A plus B. See, I have taken A plus 3 is equal to 5 and 3 plus 2 is equal to 5, right? So for simple, okay, in the rational number, irrational number, you can take the example, you can show by the example, but for natural number, whole number, integer number, it's not necessary. It is not that. Okay. Then identity element. Okay. Then third one is identity element. Identity element. How to show here? Okay. At A, okay sir, A, E belongs to Z and A belongs to Z. A star E is equal to, okay, A star E, what we should get is equal to A is equal to E star A. We should show. So, okay, for example, for okay, 2 plus 0 is equal to, okay, 2 is equal to 0 plus 2. Therefore, 0 is the identity element. Right? Fourth one. Okay. Inverse element. Okay. Inverse element, the condition is, if you write A star B should get A is equal to B star A. If I done operation, I should get the AND element. How? Let's check. 2 plus of minus 2 is equal to 0 is equal to minus 2 plus of 2, right? Therefore minus 2, okay, so I am writing here minus 2 is inverse. Okay, let's change those. Inverse of plus 2. Therefore every element in Z have inverse element. Therefore, okay sir, B is a, okay sir, here, therefore B is a inverse element of A. So here you can add B also. Here you can write A star A inverse is equal to, okay, A inverse star A is equal to E. You can show this also, whatever it may be. Next question is, okay, next question is, let A be the set of all positive and real numbers. Okay, a typical set of all positive real numbers. Positive real numbers. Okay. Question is set A belongs to R plus. I am writing, right? Positive real numbers. Okay. Can belongs to, okay. Can write subset. Subset of R, no? Okay. A belongs to, correct. Let B and defined on A. Star is defined on A. Okay, sir. Binary operation star is defined on A. Okay. By A star B is equal to AB by 3. For all AB belongs to A. For all AB belongs to A. Okay, sir. Then I have to show. Again, commutative, associative, and anti-inverse. First one, solution. Okay, sir. Let A, B, C belongs to A. Now, okay. A star B is equal to AB by 3, which is belongs to A. For all AB belongs to A. First notation. Because A belongs to any number, whatever it may be. The positive and positive divided by 3, it belongs to, okay, if you don't take 2 and 3, you can get 2 into 3 by 3 is equal to 2 belongs to A. You can take 1 by 2 into 3, right? This is 1 by 2 into 3 by 2. This becomes 3 by, this is 3 by 6, right? 3 get cancelled, na? 1 by 2 is equal to 1 by 2 belongs to A. What it means? Any random number, R number, positive numbers only belongs to A. This is the need not to show. This example in the board exam, just only action purpose. Second is commutative. Okay, first one is. Second is commutative. Okay. Now A star B is equal to AB by 3. The given. This can I write as B A by 3. This is equal to B star A. Therefore, A is commutative. A is, okay, sir. A is, it is not necessary for A B belongs to A, but follow the book. A is commutative or abelian. Abelian. Right? Fourth one. Third one is associative. Up to this is the called closed. Internal element. Internal or closed. This system, but you are not mentioning any group theory is not studied, na? So you not to mention the laws. Closure law, closed, internal element, like that. Cancel. Associative now. Okay. Now consider A star B star C is equal to A B by 3 star C. Okay, this is the whole set A. So can I write this one as A B by 3, okay, into C by 3. This is the whole, this is A. So this becomes A B C by 9. Next one is A star bracket of B star C is equal to A star, right, BC by 3. So this is BC becomes B here, right? So I am writing A B C by 3 into divided by 3. This becomes A B C by 9. Both A B, A star B, okay, close, star C is equal to A star bracket B star C is equal. Therefore, we can write this is associative element. Okay, sir. Find the identity element. Okay. Fourth one is identity element. Identity. 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 Identity element. Okay. Have to show. Okay. If you done the operation, you will get the only A. Okay. What the operation is here? Have to show A star E is equal to A is equal to E star A. What is the element here? Yeah. I should get A only. What is the end element? Just think and here. Yeah. What should I get? See, if I done the operation A star E is equal to, I should get A only. So what is here? A star E by, okay, this is what? This implies A E by 3 is equal to A. Okay, sir. Just A get cancelled. E by 3 becomes 3. This is only for calculation purpose. Okay. In exam you can take only 3. So now, okay. For all A belongs to A, there exists 3 belongs to A, right? Such that A star 3 is equal to A into 3 by A into 3 by 3. This is equal to A. Similarly, 3 star A is equal to 3 into A. Okay, this is the dot. Okay, by 3 get cancelled. A is equal to A. Therefore, 3 is the identity element. Therefore, 3 is the identity element. Identity element condition. Okay. This step is not necessary, only for understanding purpose, but this is okay. This have to write this one. Okay. Next one is inverse law. Okay. Inverse. How to write the inverse? Right. What the condition for the inverse is? Inverse element. Inverse element. Inverse element. Right. Inverse element. So what the condition is? A star B is equal to E is equal to B star A. Right? Just see how you will find inverse. A star B is equal to E. E already got the 93. Right. A, this is A B by 3. This is 3 because E is equal to 3 given. So A B is equal to 9. Right, 9. So B is equal to 9 by A. 9 by A. This is the inverse element. How you prove? Let's see. A star B is equal to A. Okay. A into what is the B? AB by 3. What is the B element? A 9 by A by 3 is equal to A get cancelled. 9 by 3 is equal to 3. Therefore 9 by A. Therefore 9 by A is inverse of A, and 9 by A belongs to A. Here 3 also belongs to right. This is 9 by A, na? 9 by A. Right. This is the method. Maximum question they will ask in the board exam, find the inverse element and find the antecedent element. They give you some complex operation, plus, minus, raised to power, something else, HCF, something, whatever it may be. But our motto is this is the method. A star B is equal to A, E1 becomes B becomes B. This is the inverse element. Right? Done. Next question is, skipping. This is the method. Okay, find the method. I told here both how to find the antecedent element and find C. This is the method for the antecedent element and this method for the inverse element. They solve many questions based on the find the antecedent element, find the inverse element, find the antecedent element, find the inverse element. Just follow this operation. A K star E, you get A. Apply the operation A E is equal to A. The corresponding elements get cancelled. The antecedent element becomes 3. So write the A star 3 is equal to A and 3 star A is equal to A. Right? Yeah. Similarly, for the inverse element, what is the formula for inverse element? Rules is A star B. If you done the operation with two elements, you will get AND element. Okay. Here we will prove you taken the AND element as 3, or you get the AND element as 3. Just use this AND element for this equation. Same operation. So you will get the 3. So 3 is dividing goes to the right side. Take the multiplication position. So AB is equal to becomes 9 and B is equal to 9 by A. Here B is the inverse. Okay, sir. Let. So here we can write also let B belongs to A. B inverse of A. Inverse element of A. You can write let A B belongs to B. B inverse element of A. Inverse element of inverse of can write inverse or inverse element of whatever it may be, right? Okay. Let's see. Okay. Different question. Same again. Same method is there. Okay. One concept is there. Okay. A supermom and infimum. Okay. We will deal with that one. These are the operation. And by that also we will solve the composition tables and some example based on this composition table. Okay, friends. This is the given is like a example and concept. I don't know whether the concept is or example. I'll take the example as it is. Okay. Okay. Let's see. Show that they give a symbol. This is called from August. This is called supermom. Okay, supermom. Okay, such that R cross R to function R, right? Defined by right of A B imply that right from the function maximum of A and B. Very important, maximum of A and B. Okay, the operation here is the V. You can call supermom. This is V. Okay, upper V, right V. Operation supermom. Okay, this is the called supermom. Is a binary operation. Okay, I have to show is the maximum of A and B, and similarly another one is this one is right now this is the lower side of AB belongs to minimum of minimum of A and B. minimum of A and B, or binary operations on R, or binary operations on R value. Okay, so A and B is the ordered pair. Order means order is very important. Order matters here unless the A equal to B. So okay, it's a mapping from function mapping from ordered pair to unique element, right? Let's consider. Okay, infimum of, okay, this is of 5 and 4 is equal to 5, and therefore 5 and 4 belongs to R, and 5 belongs to R, right? Similarly, for its infimum of 5 and 4 is equal to 4. Okay, 5 and 4 belongs to R, and 4 also belongs to R. Similarly, okay, supermum of -4 -5 is equal to -4. Okay, for -5 and -4 belongs to R, and okay, -4 also belongs to R. Okay, similarly, infimum of which one? 4 and -5 is equal to -5. So this is, and -5 also belongs to R. Okay, so but to show the binary operation, this is enough. Any one. By the means, I have to show one ordered pair. If done the operation, it leads to the unique element which belongs to the same set. That is the binary operation. So based on this, solve the some operation table. Okay, what is supermum? Okay, infimum are done right now. This is infimum. Mum. Infimum, supermum, infimum. V is called supermum. Opposite of V, downside of V is called infimum. Right? Like that, na? Yes. Supermum. Okay. This is called infimum. Like that. The binary operation. Okay. Based on this one, let's solve the one question from the composition table. Let A is equal to 1, 2, 3. Question. Let A is equal to 1, 2, 3. Set the operation table up for the supermum operation on A. Set the operation table. For the supermum operation. For supermum operation. Or supermum is V on A, right? On A. Operation table is how? Okay, A star B. How to write the operation table? Okay, this is the operation table for the. How many elements are there? 3 elements. We should have. Okay, 3 elements. Okay, sir. You should take the one and as a separate one. Okay, this is only for the operation. What is the operation here is supermum operation. Then have to take the rows similar to the number of elements. Right? 1, 2, 3. 1, 2, 3. You have to take the columns similar to the number of elements. 1, 2, 3. Okay, this is the composition table. This is the entries. Okay, first row of the first row. This is the first row. Okay, this is the first column. Column, right? First row, first column are the entries of the set A. Same entries. There is no difference. Okay, only single element, single set. Okay, two entries, two types of entries, one across the row and along the column, across the row, along the column, and at the center of this one. Okay, how to write this one? Okay, what is our condition? Supremum means the, if we taking the order pair, two elements, the maximum value of maximum value is called supremum. Okay, so again taking, if I take 1 and 1, okay sir, supremum of 1 and 1 is 1. This is not necessary, only writing. This is 1. Okay. And supremum of 1 and 2. I have to follow the row by row. Okay, row by row. 1 and 2. This is 1 and 2. This is 2. This is 2. Supremum of 2 and again 1 and 3. 1 and 3 is 3. This is 3. Similarly for all elements. Supremum of 2 and 1. 1. Okay, supremum of 2 and 2, both of them are equal, so take any one. 2 and 3, this is 3. Okay sir, supremum of 3 and 1, 3. 3 and 2, again 3. Again 3 and 3, again I have 3. Okay sir. So what is the important thing here is, okay, if it is commutable, it's abelian, just by switching the row. Okay, this is the, okay, diagonal element, na? Main diagonal elements. Okay, main diagonal elements, and these are the symmetries, right? Two and one, no? It's 2. Supremum of 2 and 1 is 2. Okay, these are the symmetries. Okay, if I have the symmetry not equals, okay, you can not say in symmetry. If the table is symmetry across the main diagonal, okay, if the table is operation table, composition table is symmetry across the main diagonal, then it is commutative. Right? Commutative, na? What is the statement is right, na? Same statement. Star as a commutative if opposite table has a symmetry across main diagonal. Yes. If the opposite table of the star is commutative, okay, then symmetry across the then the diagonal element, then it is then star. Okay, here star. Okay, star is commutative or abelian. These are the things. These are the symmetries. Okay, this symmetry. Okay, this is the main element. This is like mirror image. This is the mirror. You will get same elements across the same table. Okay, this is the basics. Okay, let's see this some operation. Okay. Let's see the. I think so. Only one or two operations we have. Composition table. Next example. Next example is. Okay. Next question is. Quite lengthy question. Okay. There will be 4 options. 4 sub questions. Okay. Example 22. Let example 22. Let A is equal to set of 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. And star be a binary operation. And star be a Binary operation. Binary operation on A defined by on A and defined by A star B is equal to HCF of A and B. HCF of A and B for all A belongs to A. For all AB belongs to A. Set the operation table for the operation star on A. Okay, sir. Then four sub questions. Okay. I'll tell the step by step. Set the operation table for this question, and I have to show some four sub questions. We solve the questions. Okay, sir. Right. Operation table. Okay. Solution. Okay. 1. Right. Okay. Can write. They are already given. Here we don't need to write the. Okay, sir. Just write the operation table. Okay. Okay. Just can write the many things. Just let. Okay. Now let. Okay. Can write now. Not let. Now A B belongs to. Not A belongs here. A is equal to 1, 2, 3, 4, 5 and A star B is equal to HCF of A and B, and A and B belongs to A here. Right? Okay, here. Okay, sir. Composition table. What the operation is? Okay, sir. HCF of A and B. Star operation. You can write HCF also, you can write the star operation also. Right? How many elements are? 1, 2, 3, 4, 5. Right? How many rows are there? Right? 1, 2, 3, 4, 5. 4. 5 rows, 5, 6 rows, 6 columns. Okay. This is the, so you can write here also star. You can write only star. You can write the HCF of AB, the function also. The name of the function. Okay. Okay. Next question is operation at the operation table. How to complete HCF of 1 and 1? 1, HCF 1 and 2, 1, HCF 1 and 3, 1, HCF 1 and 4, 1, HCF highest common factor. Highest common factor. HCF of 1 and 5, 1. And 2 and 1, 1, 2 and 2, 2, right? 2 and 3, 1, 2 and 4, 2. Can write 2 into 1, 2 into 2. 2 is equal to 2 into 1, 4 is equal to 2 into 2. Highest common factor is 2. Right? And 2 and 5, 1. And 3 and 1, 1, 3 and 2, 1, 3 and 3, 3, 3 and 4, 1, 3 and 5, 1, 4 and 1, 1, 4 and 2, 2, 4 and 3, 1, 4 and 4, 1 and 4, 4, 4 and 5, 1, 5 and 5, 1, 5 and 2, 1, 5 and 3, 1, 5 and 4, 1, 5 and 5, 5. Okay, sir. That is the question, right? Diagonal elements 1, 2, 3, 4, 5. 2, 1, 2, 1. Right? 2, 1, 2, 1, 2 1 is the second element. 2, 1, 2, 1, 2, 1. 3, 1, 1, 3, 1, 1. 4, 1, 2, 4, 1, 2. 4, 1, 2, 1, 4, 1. 4, 1, 2, 1, 4, 1. Last 5, 4, 1, 5. 5, 1, 1, 4. Right. Our table is right. First question is done. Okay. See, simple. So, okay, na? See, what the HF is highest common factor. Highest common factor. Okay, highest common factor. HF of 4 and 8. Okay, sir. 4 and 8. How to write? There are two methods. So we can divide. Okay, 8 by 4. There is the some method is there, no? Which one? Euclid's method. Okay, 8 you can write 4 into 2, 0. So this becomes 4 already, right? This also right. Also we can write 4 is equal to you can write. Okay, 4 into 1 and 8 is equal to write 4 into 2 is the highest common factor. If you are getting 0 also, this is also right. Okay, highest common factor. Factor is multiples. Okay, for 4 and 4 we have 4 and 2 have 2. We'll write this. Next question, compute compute 2 star. Okay, sir. Compute first one. Compute 2 star 3 bracket of star 4 and 2 star bracket of 3 star 4. Right? Yes. See here, just tell me from the figure. Okay. Now, from the table. Okay. But 2 star 3 is 2 star means 2 HCF. 2 star 3 is 1. Right? 2 star 3 is okay. 2 star 3 4 is equal to 1 star 4 is equal to 1. Then 2 and 2 star bracket of 3 star 4 is equal to 2 star 3 4 star 4 3 star 4. This one, this element. This is also 1 and 1 star 4 is 1 star 4 last element. Again I am getting 2 star 1. Second 2 star 1 is 1 is equal to 1. Therefore, this is associative. Therefore, star is a symbol. Can is not dimension. Star is associative. Next, compute 2 star 3 and 4 star 5. Compute 2 star 3, right? Star, continue, 4 star 5. We have for 2 star 3 is equal to 1 star 4 and 5 is 1, but 1 star 1 is 1. Okay, 2 star is 1. Then this star is commutative. Star is commutative. Commutative is the main diagonal elements. Okay, this is the okay. These are the symmetries. Yes, symmetries. Yes. Therefore, the table is how to write? If the star is commutative, question mark is there. If the star is commutative, okay, sir. Fourth one they given. If the star operation is commutative, question mark. How to write? Yes, this table is commutative because the table is how to write? Table is symmetry across the main diagonal elements. Therefore, why? Because the table is symmetry across the main diagonal elements, not elements, okay, main diagonals also, across the main diagonal elements. Right, okay, I think so. This is the last chapter, first chapter to complete. Okay, once I'm filling, let's see the time. It's okay, 46 hours. Okay, 46. Okay, students, this is the foundation. See, anyway, I have solved the basic concept and solved the basic questions. Okay, there is the time is up to you. You have to solve many questions and depends on the question demand and test paper demands. Your board exams or board test demands, school test demands. So I'm thinking I solved easy questions and medium questions. Hard questions are rarely solved because this is my first year, first one, the foundation course. Second is only for the foundation course. Okay, I am giving it free of cost, so it may be attractive, maybe interesting, maybe may not be, and helpful to all range peoples. Okay, means low category, above category, and some peoples. Okay, so those who are fresh, they can hatch. They don't, who does not know about these things, na. Some okay, very low academic performance, low academic now. Clearly, I hope you watch these videos and get the repetition. And repetition is the king of learning. Once time, you will never understand the things. Whatever it may be. You want Richard Feynman is the famous scientist, physicist, and lecturer also, teacher also. So once if you reading these also notes, you will never get the things done. You will never understand the concept. What the thing is, how to read it. That is repetition, iteration method. Now, how the iteration becomes our system. If you do the iteration means do the same thing again and again, it becomes you get finite value, very finite value. So when I'm reading this now, that repetition is very important. If you're getting the things, see, one book, one chapter has the main concept, any important concept, has the most potentiality of the asking the question from the examiner almost all time. That now, if you're solving the more questions, then you will get the more accuracy, and then you don't need to remember the formula or something else. Okay, and finally, in Canada, ನಮ್ಮ ಸ್ಕೂಲ್ ಹುಡುಗರಿಗೆ PUC ಹುಡುಗರಿಗೆ ಯಾರು PUC ಸೈನ್ಸ್ ಟಫ್ ಅಂತ ಹೇಳ್ತಾ ಇದಾರ, ಮ್ಯಾಥ್ಸ್ ಟಫ್ ಅಂತ ಹೇಳ್ತಾ ಇದಾರ, ದಯವಿಟ್ಟು ಹೇಳ್ತಿದ್ದೀನಿ, ನಂದು ನೆಕ್ಸ್ಟ್ ಪ್ಲಾನಿಂಗ್ ಇದೆ. ಲೆಟ್ಸ್ ಸಿ ಸಮಥಿಂಗ್ ಎಲ್ಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇವಾಗ 9th ಮತ್ತೆ SLC ICSE CBSE ಕಂಬೈನ್ಡ್ ಓಕೆ ಸಿಲೆಬಸ್ ಮತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ನ ಮರ್ಜ್ ಮಾಡಿ ಒಂದೇ ಫ್ಲೋಲ್ ಮಾಡ್ಬೇಕಂತ ಇದೆ. ಯಾರಿಗೆ ಎಕ್ಸಲೆಂಟ್ ಪೀಪಲ್ಸ್ ವಿಲ್ ಫಾಲೋ ದಿ ಬೋತ್. ಓಕೆ, ದೇ ವಾಂಟ್ ಕ್ವಾಲಿಟಿ ಓನ್ಲಿ. ಬಟ್ ದೋಸ್ ಯಾರಿಗೆ ಅಕಾಡೆಮಿಕ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಯಾರಿಗೆ ಅರ್ಥ ಆಗಲ್ಲ, ಅಲ್ಲೇನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ನೀವು ನಿಮಗೇನಿದೆ ಅದನ್ನಷ್ಟೇ ನೋಡ್ಬೋದು, ಅದಷ್ಟೇ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡೋದು. ಆ್ಯಂಡ್ ಸಾಲ್ವಿಂಗ್ ದಿ ಬೋತ್ ಕ್ವಶನ್ಸ್, SLC CBSE ಕ್ವಶನ್ಸ್ ಆ್ಯಂಡ್ ICSE ಕ್ವಶನ್ಸ್. ಓಕೆ, ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಎಕ್ಸಾಮ್. ಯಾಕಂದ್ರೆ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಇಟ್ಸ್ ಕಂಪ್ಲೀಟ್ ಡಿಫ್ರೆಂಟ್. ಓಕೆ, ದೇರ್ ಮೆನಿ. ಸೊ ಕನ್ನಡ ಹುಡುಗರು ನಮ್ಮ ಕಡೆ ಗೊತ್ತಿರ್ಲಿಕ್ಕಿಲ್ಲ, ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಅಷ್ಟು ಗೌರ್ಮೆಂಟಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಬುಕ್ಸ್ ಮಾತ್ರ ಫಾಲೋ ಮಾಡ್ತೀವಿ, ಯಾಕಂದ್ರೆ ಕೊಡೋದು. ಬಟ್ ಸಿಟಿಲಿ ಮೆಟ್ರೋಪಾಲಿಟನ್ ಕೋಚಿಂಗ್ ಸೆಂಟರ್ ದೊಡ್ಡ ದೊಡ್ಡ ಪ್ರೈವೇಟ್ ಕಾಲೇಜ್ಗಳಲ್ಲಿ ಆಥರ್ಸ್ ಬುಕ್ ಇದೆ, ಸಪ್ರೇಟ್ ಆಗಿ ಆಥರ್ಸ್ ಬುಕ್ ಇದಾವೆ. ಲೈಕ್ ನಮಗೆ ಇದೆಲ್ಲ ರೀತಿ ಗೊತ್ತಿರಲ್ಲ. ಸ್ಟೂಡೆಂಟ್ಸ್ ಹೇಳೋದೇನಂದ್ರೆ ಯಾವುದೇ ಇರಲಿ, ಎಷ್ಟು ನಾವು ಇವಾಗ ಕಷ್ಟಪಟ್ಟರೆ ಚೆನ್ನಾಗಿರುತ್ತೆ. ಮುಂದೆ ಈಸಿ ಇದೆ, ಬುಕ್ಸ್ ಇದಷ್ಟೇ ಫಾಲೋ ಮಾಡಬೇಕು, ಗೌರ್ಮೆಂಟ್ ಬುಕ್ ಅಷ್ಟೇ ಫಾಲೋ ಮಾಡಬೇಕು ಅಂದ್ರೆ ವಿಲ್ ಗೆಟ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್. ಅಂದ್ರೆ ನಿಮಗೆ ಯಾವುದೇ ಡೀಪ್ ಅರ್ಥ ಆಗಲ್ಲ. ಹಂಗೆ ಏನಾಗುತ್ತೆ, ಬರ್ತಾ ನಮಗೆ ಸೈನ್ಸ್ ಕಷ್ಟ ಆಗುತ್ತೆ, ಅದು ಕಷ್ಟ ಆಗುತ್ತೆ, ಇದು ಕಷ್ಟ ಆಗಂಗೆ ಇರುತ್ತೆ. ಓಕೆ, ಅದು ಕೂಡ ಹಾಕೂಡ್ದು. ದಯವಿಟ್ಟು ಕನ್ನಡ ಮೀಡಿಯಂ ಹುಡುಗರಿಗೆ ರಿಕ್ವೆಸ್ಟ್. ಓಕೆ, ಚೆನ್ನಾಗಿರೋ ಕಾಲೇಜು, ಕ್ವಾಲಿಟಿ ನೋಡಿ. ಯೂಟ್ಯೂಬಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಫ್ರೀ ಆಗಿರ್ತವೆ, ಡಿಸ್ಟ್ರಾಕ್ಷನ್ ಆಗದೇ. ಟೆಕ್ನಾಲಜಿ ಇಸ್ ಅ ಬೂಸ್ಟ್ ಆ್ಯಂಡ್ ಬೂನ್ ಬೋತ್. We can boost our knowledge, we can boon our career also, right? Depends on the also. And technology is a friend and foe. Foe means enemy. So technology we can use it as a friend also to help our build up your career or build skills. If you can use it as a foe also to kill ourselves, to destroy ourselves. That's the social media, whatever it may be. depends on our mind control. So for blaming on the invention and discoveries, we are failing ourselves. ನಾವು ಸೋಲ್ಕೆ ಒಪ್ಕೊಂತ ಇದೀವಿ, ಈ ತರ ಬೇಡ, ಈ ತರ ಮಾಡ್ಬೇಕು, ಈ ತರ ಬೇಡ ಬೇಡ ಅಂತ. ಯೂಟ್ಯೂಬ್ ಎಲ್ಲ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ, ಜಗತ್ತು ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಇದೆ. ಯಾವ ಕಾಲೇಜ್ಗೆ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಎಷ್ಟೋ ಜನ ರೈತರಾಯ್ತು, ಬೇರೆಷ್ಟು ಟೀಚರ್ಸ್ ಆಯ್ತು, ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಫಾಲೋ ಮಾಡ್ಕೊಂಡು ಎಕ್ಸಾಮ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ರೈತರು ಬೆಳೆಗಳು ಬೆಳೀತಾ ಇದ್ದಾರೆ. ಸೊ ಅದೇ ರೀತಿ ನಾವು ಇಲ್ಲಿ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ರೆ ಚೆನ್ನಾಗಿರುತ್ತೆ. ಟೆಕ್ನಾಲಜಿ, ಸೋಷಿಯಲ್ ಮೀಡಿಯಾ ಯೂಸ್ ಮಾಡಿ, ದಟ್ ಶುಡ್ ಬಿ ಲಿಮಿಟೆಡ್. ಆಪ್ಟಿಮಲ್ ಲೆವೆಲ್ ಮೀನ್ಸ್ ಅಂತ ಗೊತ್ತು. ನಾವು ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು. ಡಿಸ್ಟ್ರಕ್ಷನ್ ಆಗ್ತಾ ಪರ ಶುಡ್ ಲೀವ್ ಇಟ್ ಎಟ್ ಎನಿ ಕಾಸ್ಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ನನಗೆ 9th ಮತ್ತು 10th. ಓಕೆ, ಅದು ಯಾವ ಥರ ನನಗೆ ಇಂಟ್ರೆಸ್ಟ್ ಇದೆ, ಪ್ಲಾನಿಂಗ್ ಇದೆ. ಲೆಟ್ಸ್ ಸಿ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್. ಓಕೆ, ಅಪ್ ಟು ದೇ ಆ್ಯಂಡ್ ಥ್ಯಾಂಕ್ಸ್ ಫಾರ್ ದಿ ವಾಚಿಂಗ್ ಮೈ ದೀಸ್ ಕಂಟೆಂಟ್ಸ್. ಪ್ಲೀಸ್ feel free to comment. Okay, your comments are the my debugs. Okay, your comments, positive or negative, almost all debugs to my software. I have to do update. When I have to update, then I have to take the bugging is there. ಎಲ್ಲಿ ನನಗೆ ಸಮಸ್ಯೆ ಆಗ್ತದೆ ಅಂತ ಗೊತ್ತಾದ್ರೆ ಮಾತ್ರ ಡಿಬಗ್ ಮಾಡೋದು. ಗೊತ್ತಾಗಿಲ್ಲಪ್ಪ ಅಂದರೆ ಸ್ವಲ್ಪ ನಾನು ಪಾಸಿಟಿವ್ ಕಮೆಂಟ್ ಮಾಡಿ. ಓಕೆ, ಟ್ರೈ ಮೇ ಬಿ soon with the new concept, new chapters and new times, new schedules. Right with me. Okay, bye. Thanks for watching, and once again, thanks for everyone.